That's something I remember. At least when you end up at hydrogen bonds, you typically would have the other two prior as well. So now number 7. What is the difference between mixture and compound? I do believe we touched this a little bit, but we can now further delve into this. Sorry. The difference between mixture and compound, okay? So, another way to explain this question actually is kind of like the, how do I put this? Actually, no, that's not a good way to explain it. I was going to do the whole squares and rectangles thing, but you'll see that a compound doesn't always have to be a mixture and vice versa, okay? If I had one single H2O molecule, okay, as I said earlier, this would be a compound, a molecular compound, because it's composed of different things, okay, right? But this wouldn't be a mixture. Although it's quite impossible to have one single molecule of water. If that was the case, it wouldn't be a mixture, okay? Because of the fact that the key thing for mixture is now you're no longer dealing with, I guess, one molecule. You're dealing with multiple molecules. A mixture needs in fact, that's actually a perfect way to put it. Mixture needs multiple, I wouldn't even say molecules, yeah, actually no, molecules is a perfect word. Molecules, okay, that is what a mixture needs. And a compound, actually, this is the part that's kind of conscious of how you can relate them. Compound needs multiple atoms. This right here is a distinction between compounds and mixtures. What I mean by this water compound has multiple atoms but not multiple molecules. This would be a compound of H2O, but not a mixture. Well, not a mixture. And actually, I'll specify here another difference that needs multiple. Let me move this, because this is where it gets a little bit more wonky. Is that it needs multiple different molecules, okay? And that is very important because that is for compounds. It doesn't really, molecular compound needs multiple different atoms, so they're actually quite related. And the reason why I wrote it like that is because you hear of molecular compounds and molecular elements, as I discussed earlier, molecular elements being composed of the same type of atom. Okay, so like O2 is 2 of oxygen. A compound, molecular compound now, instead of molecular elements, is like this H2O, the water molecule, okay? That is multiple different atoms. A compound would also be like NaCl, as we discussed earlier, because just one sodium, one chloride, okay? This is also a compound because it's multiple different atoms. Now, as we're saying, back to the whole relation to mixture, if I had 2 water molecules in the same place, okay, which is also very hard to do, but still, for this example, this is still not a mixture, okay? Because it's multiple of the same molecule. But if I were to throw in a sodium chloride, okay, alright, like that, into that same, I guess, bin, this is now a mixture because it has multiple different molecules. Even if I were to remove one of the water, this is still a mixture. It's a 50-50 mix. Half NaCl, half H2O. But exactly, that's the key difference there between mixtures and compounds. Compounds deal on an atomic level, mixtures deal on a molecular level. So it's a step up, okay? So compounds atomic level, mixtures molecular level, okay? And what differs from each other is how the elements constitution the samples are contained. Compounds are materials that contain both elements, bonded elements and molecules, exactly. So it's atomic level in terms of bonds, and mixtures don't involve bonding, okay? It's now on a molecular level. These consist of different atoms or molecules in a specific space. They will share some in terms of hydrogen force. In fact, that would be actually a better name. Some hydrogen bonds, like in this previous question, they will share some different types of forces in terms of the when they interact with each other, okay, like when they float by. But it's not like actual strong bonds formed unless there's a bond breaking and another bond forming. So with that all being said, exactly, mixtures are on a molecular level, so these molecules are not bonded to each other, and compounds are dealing on an atomic level where the atoms are bonded to each other. Okay, that is a key difference of mixture and compounds. Okay, this is correct nonetheless, because it does talk about the bonds for compounds and a lack of bonds for mixtures. So let's move on to question 8. All right.